Okay, welcome back, folks. We're going to look at multiplying and dividing those rational expressions today. Next time we'll talk about adding and subtracting them. Our first lesson we dealt with, we talked about non-permissible values and how we can simplify these. So those non-permissible values, again, are the values of the denominator that make your fraction zero. Because remember, we don't want to ever divide by zero. We do get that error, and it's not really possible. So we want to try to avoid that where we can. Now, before we do that, we have to remember how to work with fractions. So those two operations of multiplication and division, when you're dealing with a fraction, they're actually quite nice to deal with. If you're going to do multiplication on a fraction, you're really just going to multiply straight across. So numerator to numerator, 12 and 5 will make 60. Underneath your 10 and 4 will create 40 for you. And you could reduce that as well, dividing both the top and bottom by the same factor. Pick the biggest one possible here. If you use 20, you're going to reduce that to 3/2 in lowest terms. Okay, division is very similar, except what you're going to do, you learned a shortcut before, where you could flip the second fraction and change it into a multiplication question. And we could do the same thing with those rational expressions as well. But there is something else that we're going to have to think about when it comes to the non-permissible values. So if you multiply straight across, you're going to get -24 over -48, and that will reduce to +1/2. The negative signs are going to cancel. Okay, so let's go do this with a couple of expressions. Now this one says evaluate. It doesn't ask us to state those non-permissible values, but we will just for practice, just to get us familiar with that. So I've got two fractions here that we're going to look at the denominators to determine whether or not any of them have a problem. So the first one has a variable on the bottom, and we can't let that variable be 0. So this one has a non-permissible value of 0. X cannot be 0. Now we can go ahead and start simplifying. So you can multiply straight across and get -2x² on the bottom. X and 5 multiplied together give you 5x. You can reduce that because you can take a factor of x out on the top and the bottom. So you're going to get -2x over 5. Okay. Again, your non-permissible value, x can't be 0. Now I know there's no x on the bottom here, but if you were to plug it back into the original expression, you would have an issue. So just remember to carry that through all your steps. Second one's got two fractions. Again, denominators both have variables. So we're going to have some non-permissible values to think about. For the first fraction, if I make x equal to -1, that'll give us a problem. So x can't be -1. Or in the second fraction, x can't be 0 for the same reason. Now I can go and start simplifying. So if we go to multiply, again, go straight across, you could do -2 multiplied with x plus 1, and then same thing on the bottom, and then I could try to simplify after. But if I already look at this, I've got a factor of x plus 1 on the top and a factor of x plus 1 on the bottom. Essentially what those are going to do is cancel out anyways. So let's just cross them out. Now, if I didn't do my non-permissible values already, it would look like one of them got canceled out and disappeared. But you can't really do that because technically, if you put that value of -1 back into your original expression before you cancel things out, you're losing out on that non-permissible value. Okay, it is still technically there. So this one simplifies to -2 over -8x. And then if you reduce the fraction, the coefficients, you get 1 over 4x. There it is in lowest terms. Your non-permissible values are still present. Okay. Same thing with the other one. I've got, again, two denominators with variables. This time it's division. So my non-permissible values are going to be 0 for both since it's just x. Okay, so x can't be 0. Now, since it's division, we're going to flip this second fraction and then multiply. So if I were to have a variable on top of this one, I'd have to think about that also as a non-permissible value scenario, because as soon as I flip it and put it into the denominator, I'm going to have an extra non-permissible value to worry about. Here it's just a constant, -9. I don't have to worry about it this time. So let's flip it and then multiply. So my x² goes to the top, -9 on the bottom. Okay, so now I can multiply straight across like before, but let's cancel out one of those x's first since they're one's on the bottom, one's on top. So we're going to end up with -2x over -9. Simplify your signs. That'll give you 2x over 9. Can't really reduce that anymore. And again, your non-permissible value, x can't be 0. Last one on here. Now I've got a variable in the top part of that second fraction, so I have to worry about that one also as a non-permissible value, because as soon as we flip it to do our multiplication, that goes into the denominator, which could leave me with an issue. So let's look at those denominators first. If it's 5x, the only value x cannot be is 0. So x can't be 0 for that one. If it's 20x, the same logic, x can't be 0. So the one up above, x plus 2. If I make x 0, 0 plus 2 is 2 times 2 is 4. So 0 is fine for this one. So x can't actually be negative 2. That's the value that will zero out this set of brackets. Okay, so I've got two distinct non-permissible values this time. Now we can go ahead and start to flip this and simplify. So first fraction is going to stay the same. Second one is going to flip over. 2x plus 2, and now we can start to reduce things. So if you notice, you're going to have an x plus 2 being able to cancel out, and an x also being able to cancel out. Okay, so you're left with is really just 20 over 10. Okay, so 20 over 10, because that's going to be my 5 multiplied with my 2. That one simplifies to being a whole number value, just 2. Okay. And I still technically need those non-permissible values. X can't be 0 or negative 2, because if it is, I'm plugging it back into the original, and that's going to give us a problem. Okay, sometimes it simplifies just to a whole number, which is kind of nice. Okay, if you flip it over, we got another example here. Multiply numerators, denominators, simplify by dividing out any common factors. Essentially, that's what we did before. So I'm not going to simplify these ones and show you all the steps. I will give you the answers. If you want to try the 3 of them out, stating your non-permissible values as well, you could do that. So you could pause it here, try them out on your own, and then rewatch the video to get those answers. So I'm just going to write you the final answer here. Over 4, where c can't be 0, or the middle one works out to be 10x plus 3 over 3, and for that one it looks like x can't be 1 or 0, and then for the last one simplifies out to being 4 over 7x plus, that's going to be x plus 4. Okay, and then your non-permissible values, x cannot be 1/2, or x cannot be negative 4. Okay, those should be your answers, along with the correct non-permissible values. Example 2 underneath, we will do these ones because they deal with division. It's a little bit different. There's something extra to think about. So we'll do these ones. Okay. So let's think about our non-permissible values first. It is division, so I need to think about both denominators along with the numerator of the second fraction, because when I flip it, it goes to the bottom. So these two are both constants, no variables to worry about. Just the top part of that second fraction. So if n is 0, that will zero out the whole top. So n can't be 0. Now I can go simplify and everything is fine. So 5n4 over negative 2, multiply it with 6 over 5n squared. And now you can start to reduce things. So let's square this first, or just square that factor on the bottom, I should say. So 5n4 over my negative 2. Multiply with 6, so it's going to be 25n squared. Now you can reduce everything and put stuff together. So you're going to get a 30n4 on top over negative 50n squared on the bottom. Reduce it, you get negative 3n squared over 5. And again, n can't be 0. Okay, middle one. When everything's factored like this, it makes it a lot easier to deal with. So let's do the non-permissible values first. X can't be 0 from the first denominator. X can't be 2 from the second denominator. That one also has a factor of x, but we've already taken care of it. We already said x can't be 0. Top part of the second fraction, x also can't be -1. Okay, because again, when that fraction gets flipped, that value goes to the bottom, could give us a problem also. So I need to check all 3 of these. Now you can start to simplify. So flip over that second fraction. So 2 times x plus 1 over 3x, multiply x, x minus 2, and that's a 4x plus 1. Now we can start to cancel things out. So I see an x plus 1 in the left. I see an x plus 1 on the bottom right. Those will cancel. X's also will cancel out. So you're going to be left with 2x minus 2 over 3. Nothing else you can really do there. Don't bother distributing the 2 inside. It's better to see it like this. It's factored. It's more simplified. It's nicer to look at. So your non-permissible values are going to always go after 0, 2, and -1. So there's your final simplified answer. Last one then, not really a whole lot you can do here. As long as a is not 0, we're going to be okay. So what we could really do is just multiply both the top and the bottom by a to make this look a little bit nicer. So distribute that to both terms in the numerator and the denominator. So that's going to leave you with 5a minus 1 and 5a plus 1. Okay, at that point, there really is nothing else you can do. We can leave it just like that. Okay, underneath, when you're dividing or determining non-permissible values, when dividing, just remember that you have to consider that numerator of the second fraction. So consider the numerator of the second fraction, because when we divide, that one gets flipped over and goes into the denominator place now. Okay, that could leave us with an issue. So when we turn it over, there's a couple more here, which I don't know. I don't think I'm going to give you both of these. I think I'll do the division one. So I'm going to give you the answer for the first one along with the non-permissible value so you can try it out. Now it's very helpful to factor everything completely before you start to simplify. So factoring it will give you all of those non-permissible values. Actually, I take that back. We will do both of these. So let's factor this first. Okay, so the first numerator is going to get factored into x plus 4 and x plus 1. Bottom one, if you factor out a greatest common factor of 2 first and then use your sum and product rule, it gets factored into x minus 2, x minus 2. Second fraction, factor out a 4 from the top, you get x minus 2. And the bottom part here, the second denominator is a difference of squares, so x minus 1, x plus 1. Just double check, make sure I got the signs right. I did. Okay. So now we can go state our non-permissible values first. So look at the denominators of both fractions, figure out what values of x will zero this out. So it looks like x cannot be 2 from the first one, which also takes care of the second one. X can't be positive 1, and x can't be negative 1. Okay, so those 3 values will zero out our denominators. If one of them is 0, they're all 0 because it's multiplication. I don't need to worry about the numerator here because this was a multiply question. We're not flipping this fraction over, even though it gets taken care of anyways. Didn't really have to. And now I can go simplify. So if it's multiply, imagine that all the tops are getting put together, all the denominators are getting put together. So now you can start to cancel things out. So we can cancel out an x minus 2 from both sides, and x plus 1 from both sides, and that looks like it's about it. Okay, so we're going to be left with 4 x plus 4 over 2 x minus 2 x minus 1. Okay, so all my factors are simplified, but I can simplify those coefficients as well. So as a final most simplified answer, 2x plus 4 on the bottom, x minus 2, x minus 1. And again, my non-permissible values, x can't be 2, 1, or negative 1. Okay, this would be as simplified as we can take it. Now remember, those non-permissible values always come from that original expression. Don't just find them on the simplified version, because sometimes things get canceled out and you won't actually see them. Okay, so let's talk about this division one. I'm actually going to move this a little bit. It's not in the way. Okay. So this is a division type problem where you have to think about this denominator, and this numerator. Okay, because this second fraction is going to get flipped over, I could have a problem with this numerator as well. So let's factor it first and then determine those non-permissible values. So in factored form, we're going to have, hopefully I did this correct. I put a 2 there. Oh, that's why. 2x, it should be 2x. Oh, no wonder it didn't work the first time. Okay, let's take a 2 out. So we'll have 2x minus 5 underneath x plus 3. Divide. Now, if I factor both of those, I should have, let's say that, is that a 3? Yeah, so 3, 2x minus 5 on top, 2x minus 5 on top, over, a 2 comes out, and that will be x minus 3, x plus 3, it should be. Yep. Okay, so I'll let you factor those, but this is what you should have when it gets simplified. Now we can go look at those non-permissible values. So from the first fraction, my denominator x plus 3, that means that x can't be negative 3, or else that'll make it 0. From the second fraction, I've already taken care of this one, where it's x plus 3, because that was the same as the first one. So now I know that x cannot be positive 3 either, because that would make this set of brackets 0. Now I have to think about the numerator. So I have the same factor twice, a 2x minus 5. So if I need to figure out what that NPV is going to be, 2x minus 5 can't be 0. So if I try to make it equal to 0, I can figure out what x is. So 2x is going to be 5, x is going to be 5 over 2. So I know that x can't be 5 over 2 because that value would make it equal to 0. Okay, so I have 3 non-permissible values this time, and I've accounted for all of them. Now I can go ahead and simplify. So let's flip that second fraction over, change it to a multiply question. And that will be my x plus 3. Change it to multiply, 2x minus 3, x plus 3. Underneath my 3, 2x minus 5, 2x minus 5. Okay, so now let's see what we can cancel. I can cancel 2x minus 5. We can cancel the x plus 3. Now it looks like about it. So if we go to write this in simplified form, I still have this 2, so I'm going to circle everything I still have to deal with. Okay, so everything circled or boxed in red is still there, so I can multiply now the numerators together, denominators together. So 2 times 2x minus 3, that'll leave me with 4x minus 3's. And underneath, I should have a 3 times a 2x minus 5. So 3, 2x minus 5. Okay, my non-permissible values are still present, so x can't be equal to negative 3, 3, and 5 over 2. Okay, everything's as simplified as it gets. I can't reduce these factors anymore. Can't simplify those coefficients to give me a nice number. This is my final answer. Okay, one more underneath. It looks pretty complicated. It's just longer. It actually factors quite nicely. So let's take care of that one. If you want to try it out for yourself, go ahead. I'll do the whole solution here also. So you can give it a pause, try it, and then come back and see how you did. So if we go to factor everything first, we're going to end up with a minus 1, a plus 4 divided by, and then we'll go factor everything. So this will turn into, along the top, a plus 5, a plus 1, underneath a minus 1, a plus 1, multiply, This one turns into an a plus 4, and I believe an a minus 1. This one on the bottom is going to be a minus 1, a minus 1. Okay, so everything's factored. Now, when I'm thinking about determining those non-permissible values, I do have to consider the first denominator, the fraction that's by itself. But since this is a division question, I can't only consider all of the denominators here, I have to consider all of the numerators as well, because that whole fraction is going to get flipped, the whole entire set of brackets. So I need to consider basically everything except this first numerator. So if we go to do those non-permissible values, we can say a can't be negative 4, a cannot be 1, a also can't be negative 1. I've considered that here already. I've already considered a can't be 1, a can't be 1 for this bracket, a can't be negative 4 here, a can't be negative 1, I've got that covered, a also can't be negative 5. Okay, so I do have 4 distinct non-permissible values that we've taken care of. And if you want, you can place them in order big to small, small to big, doesn't really make a difference. Negative 5, negative 4, negative 1, 1. Okay, so a can't be any of those values. Now we can go simplify. So let's flip the second fraction, so the entire set of brackets. So 4, change it to a multiply question. So all of these are going to flip now. That'll be a minus 1, a plus 1. On the bottom, a plus 5, a plus 1. Multiply, a minus 1, a minus 1. Underneath, a plus 4, a minus 1. Okay, we flip this whole set of brackets because it was division, change it to multiply. Now all of these are being multiplied together. All the numerators are attached now. All the denominators are attached. Now I can start canceling things out. So if there's an a minus 1 top and bottom, I can cancel out that pair. If there's an a plus 1 top and bottom, I can cancel out that pair. And any other pairs, I'm trying to look. I don't see any more a minus 1s on the bottom that can cancel. That means I don't see anything else that could possibly go together. So that means we have as a final answer a minus 1, but there's 1, 2, 3 of them, so a minus 1 cubed, over a plus 4 squared, because there's 2 of those, and then a plus 5. So a plus 4 squared, and then a plus 5 term. And again, those non-permissible values. A can't be negative 5, negative 4, negative 1, or 1. Okay, so really only 2 steps. The factoring was the important part to find those non-permissible values, but then everything kind of just cancels out anyway. So if you can factor it completely first, find those non-permissible values, then simplify, makes your life a whole lot easier. Now, once you get to the end here, don't multiply everything back out. You can leave it in this factored form, and that's perfectly acceptable. If you start doing distributive property and FOIL and all that kind of stuff, it makes it a whole big mess that you don't want to have to deal with. So leave it in that simplified form, and everything is just fine. Okay, so the next time we see each other, we'll talk about adding, subtracting, and then how to deal with word problems. And that's essentially our entire unit on rational expressions. Again, if you're having some issues, make sure you let your teacher know, and they'll be more than happy to help you out. See you next time.